see me?
No.
Can you see my hands?
I can see your
Can
hands.
you see my hands and can you hear my voice?
I can hear your
Okay.
voice and see your hands.
As you know, if you've been watching, we just came from Boca Dump Beach. South Inlet Park, we're 1180 and 1200. The buildings that are dumping their wells back into the ocean. And we took some water samples. This is from the well itself. That's A. This is ocean water that I got right off the beach. And this is some water I got from the inlet, which was kind of brackish because it's low tide, so just a comparison samples. We're going to go ahead and, I need the dropper. Go ahead and take some samples here and test them. You test them right in front of you so you can see that I'm not making this up. Okay. Now keep in mind this is the water that's coming out of that well. But let's start with B, which was the ocean water. Okay? Let me just make a note here. A, well, return.
Write down. No word. That's okay. That's okay.
Tell me.
I can see it.
B, ocean water. And C is the inlet. Well, the intercoastal, let's just say inlet. And it's an, let's see, outgoing, but it's low tide. And being low tide, I might expect to see these numbers a little higher because there's a lot of brackish water in there. But let's start. Let's just go backwards. Let's work with the inlet water. This is inlet. Clear water. All right. This is a phosphate test. Chart goes up here.
The chart?
Chart.
The chart?
Okay, sorry about that. Couldn't find our chart for a minute. Okay. Here's our chart.
Mix it.
Up.
Mix it a little.
I mixed it.
Yeah.
Now that's intercoastal water. So,
Bring it over here a little. No, like closer to the thing. Mm-hmm. Hold on. Okay. Yeah, maybe it's one.
so let's.
Not quite that dark.
This is 1, maybe a little under 1.
Light.
Sorry, guys.
No, it's not that dark. It's probably like right there. Under
Somewhere
between 0.5 and 1.
Yeah, between 0.5 and 1. Okay, stand by. I'm going to rinse this out with some distilled water to clean the vial, and then we'll move on to ocean water. And in case there's any haters out there, this is distilled water cleaning solution, and this came from a scientific laboratory that provided us with our turbidity meter. So I'm not washing this out with tap water or anything out of the norm. This is a cleaning solution specifically for this purpose. Okay. Clean vial. So we're going to call that one, let's split the difference and just say it was 0.75. Just call it 0.7. I'm erring on the positive side. I think it was more closer to 1, but I'll give them a 0.7 on that one. Okay, ocean water.
Okay, that's better.
This is clean ocean water. There's a little bit of sand in there because they took it right off the beach. Now you stir this, you don't shake it up.
It's yellow. It's sort of yellow. It's a little it's in the light. You have the light.
One second, I'm going to light this up. So
Yeah. Oh, that's better. Well, it's a weird.
Turn it to a lower setting because you did.
There we go. Yeah, you can see it better now.
All right, so let's call that a 0.05. It's probably lower. It's probably closer to 0.
Hmm. Okay. That's
I'm going to
good.
call
Yeah,
that
you can
0.
see it.
I mean,
That's
that's a 0.
Yeah.
Okay. Okay. Ocean water. 0.0. And this was 0.7. And this is probably from fertilizer and runoff and stuff from the lake, and we're always expecting to see that number a little higher. Okay, so I'm going to rinse this out with distilled water one more time, and we'll check the well. Anybody wants to donate some better test equipment, let me know. Greatly appreciated. You may say, oh, the vial is blue, but it's not really the vial. The label is kind of stained from me touching it. Okay, so let's go to our final test here. And
That's the.
yeah, I'm trying not to get any sand when I pick it up. Alright, now this is directly out of the well. Directly out of the well, I actually inserted a tube inside the well. If you saw the earlier video, I inserted a hose inside the tube so we wouldn't pick up any ocean water. And I had a little manual hand pump, and I pumped some of the water out directly so we didn't get any mixing with the salt water. Okay, so let's take a look at this one. Yeah. Sorry, guys. I don't know if you can see it.
Drop the one. I'm still going to get some green.
It's hard to hold it where you can see it. Okay. All right. I'm going to call this closer to 1. And yesterday when I checked this, I looked at this yesterday and the reading was actually at 3 yesterday. All right. Now I'm going to explain to you why. I'm going to do one more test. I'm going to show you my tap water to show you what my tap water is. And then I'm going to explain to you why, like when I took this sample today, it wasn't dead low tide. The tide was still going out. I'm going to explain to you why now I'm getting closer to a 1 versus a 3. So bear with me. I'm going to get some tap water. I'm going to show you what tap water looks like. this regular tap water. Okay. I'm running out of solution. 21.
Yeah, 21.
Okay, so let's. D is tap water. And that's 0.1. aka drinking water is at 0.1. So let's review. Not rocket science, okay? If the city of Boca and FDP don't understand this, I don't see what the problem is. The well, 1.0. Acceptable drinking level, 0.1. Inlet and outgoing low tide, 0.7. Ocean water, 0. So let's check something else here too, because this is a simple salinity meter, and if this was a freshwater well, these numbers would be here at 0. So I'm going to show you what tap water first. Drinking water, acceptable drinking water. Fresh water that would come out of a well, drinking water, 0. The scale is buried out. So, drinking water. Zero salinity. Now, let's go right to ocean water. It's going to be salty, we know that. It's ocean water. Okay, salinity in the ocean on surface water, 1.027. Alright, 1.027 on the ocean. Now, the well water should be 0 because it's supposed to be drinkable, acceptable drinkable water which comes out of the aquifer. So if the well is not contaminated, this should be 0. Let's go here with the well. And I waited, there's some sand on the bottom, but I waited long enough that the sand settled out. Okay. stuck a tube inside that pipe. So there's no way ocean water got back into this vial. Here's our measurement here. 1. Number.
Ah! Right? I guess okay. Now I can see it. Yeah.
1 point. What is that number, Adrian?
020 or between 1.020 and 021.
Okay. Let's keep that number in mind. Now, we're going to move over to the inlet water, which is brackish.
Hold on. It just goes out of focus.
This is brackish water. It's a mixture of stuff from the lake, the inlet, the canals, everything. Amazing.
Up a little higher.
Totally amazing.
Yeah, it's just a little bit higher.
Just slightly higher over what the well is.
Mm-hmm.
Okay. So let's call the well 1.020.
Oh, is that the inlet water? Well, it was
1.020 salinity. The inlet water, we're calling the inlet water. Sorry guys, I can't see and do the same time.
1.02 between 201 and 22. Oh, there it is. It's probably closer to 0.22. 1.022.
Okay, let's err on their side, their favor here. Let's just say the salinity is 1.022. And our drinking water is at 0. Ocean water, checking ocean water here at the surf, it's always a little higher than normal. We said that was 1.026. Okay. Simple science. And I know all the people from the FDP are going to tell you these tests are not, you know, scientifically proven because it doesn't go through a chain of custody, an independent agency, whatever. You wait to hear for yourself. You saw the video earlier where I got the samples from the beach. I mean, just because we don't have $1 million laboratory here doesn't mean that these tests are very far off. Let's do some basic deductions here. Basic deductions. A well that should contain potable water, which is water suitable to drink, should never, ever have a phosphate level this high. Okay? Out of a natural well, unless you're in some polluted grounds, your well will come out no higher than this. And usually a well, a good well, is somewhere in the nature of, a good well would be somewhere in the nature of 0.01, not 0.1. So, unacceptable there. Now, I'm going to tell you why this well has this high number. At low tide, what's happening, I got to draw you a picture. Here, take that, please. I'm going to draw you a picture here. began with my rudimentary skills. Here's the ocean. Here's the building. Here's their well. Okay? Normally, their well only picks up water from here, which is our aquifer, where we get our drinking water from. This well is so old, these pipes are all corroded. All corroded in here. This ground is all saturated with water. Water from where? Where does that water come from? Okay. The intercoastal is over here. That's the intercoastal over there. And all the dead, decaying muck, matter, fertilizer, all that stuff that's leached into the ground here, this is all water in here under the earth. It's all mud. If you dig down in your backyard, you're going to pick up mud and all that stuff. This pipe is full of little holes. Okay? And as the tide is going out, it's pushing more in here into this pipe. Okay? So now the water level is dropping here. And normally this is saturated wet, so it's getting more fresh water. But as the tide is going down, the pump is sucking from all these little cavities harder, because that's the point of least resistance. It's sucking that up, and it's pumping that into their exchanger and out into the ocean. So I know now for a fact that well is contaminated. So not only are they violating the FDP and the Clean Water Act, this well is also contaminated and needs to be closed off and sealed up. Fact proven. Numbers don't lie. Simple science. I'm not a rocket scientist. I'm a simple fisherman. But enough is enough. Let's get it together. I'm out. Peace out, guys. Gotta go to work.